Right. In the last class we completed oxides. Let us continue oxides. You tell me what happens to acidic nature of oxides as oxidation state increases. Tell me. If oxidation state of nitrogen increases, then what happens to its acidic nature? Increases or decreases? Bhakti, Adiba? Increases, right? Okay, continue. Acidic nature of oxides. Concept of oxides. Oxides. Yesterday I given three formats for oxides: N2O5, N2O4 and N2O3. Right. Keep heading oxidizing power. Continuation of yesterday's class. Oxidizing power. N2O5 is a good oxidizing power, having good oxidizing power than N2O4, N2O3. See, this is applicable to other elements also. So you can write one general format: E2O5, E2O4, E2O3. Okay. Why? What is the oxidation state of nitrogen here? Nitrogen oxidation state is +5. +5 means it is deficient. Okay, if more is the positive charge, more will be the deficiency, right? So nitrogen in the +5 ready to take electrons from the others, remove electrons from the others. That's why its oxidizing power is more. Removing electrons from others is called as oxidizing nature. Clear? Here oxidation state is more. It is having more capability to gain the electrons from the others. That is called as oxidizing power. So remember this format. This is a good oxidizing agent. Which is good oxidizing agent? N2O5 is a good oxidizing agent. Okay, got it? Right. Note down. Just a second. Right. Let us discuss some important oxides and their properties. Oxides of nitrogen. Just now I explained, no? Bhakti, what is its oxidation state? Nitrogen oxidation state. Nitrogen oxidation state. In N2O5, +5. +5. See, it is having deficiency, more electron deficiency. +5 means we removed 5 electrons from the nitrogen. That is the meaning. We removed 5 electrons from the nitrogen, means it lost electrons. So it is highly deficient. Highly deficient. So what it will do? For example, some magnesium is having electrons. Magnesium is having electrons. It takes immediately 2 electrons from the magnesium and converted to some +3 state. +3 state. Because it is deficient. +5 means deficient. Okay, more is the positive charge, more will be the deficiency. This property, taking electrons, removing electrons from the others, is called as oxidizing property, oxidizing nature. Okay. Among these three, which is having higher positive charge, that will be the more oxidizing agent, having more oxidizing power. Okay. Clear, Adima? In case of remaining, oxidation state is small, means less deficient, so they are having less tendency to accept electrons. Okay, right. Let us discuss some important oxides and their nature. More probability to get the questions on this. Okay, I'll tell you that oxides. Keep first one, NO. Sorry. See how questions will come on oxides of nitrogen. You'll get questions like this. Which of the following is neutral oxide? Which of the following oxide is paramagnetic oxide? Very, very important model questions. Which of the following is diamagnetic oxide? Which of the following exists as a liquid? Physical states also coming. Which oxide exists as a colorless gas? Which oxide exists as a brown color gas? 15 is odd number. Odd number means paramagnetic property. I will show you why it is a paramagnetic. Once go to chemical bonding, sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. You tell me this is having how many electrons? Less than or greater than or equal to 14? Greater than or equal to 14. When number of electrons are greater than or equal to 14, which configuration we use? Sigma 2pz pi 2px is equal to pi 2py. Are you getting idea? Pi star 2px is equal to pi star 2py. Yes or no? According to chemical bonding, MOT, molecular orbital theory. Now we have to fill 15 electrons. 1, 2, 3, 4. 4 into 2 means 8 electrons per over. 10 electrons were completed. 12, 14 electrons were completed. And one more electron. Why I am giving this configuration again? Sometimes if paper is very tough, we will get questions like this. We know condition for paramagnetism is presence of single electrons. Once look at this, here single electron is present, right? Paramagnetic, okay. Solution means explanation is given why it is a paramagnetic. So this is the explanation for that. How question will come? Next level question. NO is a paramagnetic oxide due to presence of electron in which molecular orbital? Look at that. Tell me. In which molecular orbital? Antibonding or bonding? Antibonding or bonding? And give the name also. Pi star means antibonding. Antibonding molecular orbital. Bonding means without star. Antibonding means with the star. That is important. NO is a paramagnetic due to presence of a single electron in antibonding molecular orbital. Pi star. Clear? Remember that point. So I am giving that point. See, neutral oxide, number of electrons are 15. So odd number. So paramagnetic. This point is very, very important. Which of the following oxide is a paramagnetic oxide? NO is a paramagnetic oxide. And you tell me, paramagnetic and color property both are related to each other or not? Generally, if single electron is present, then molecular species is a paramagnetic. At the same time, it is colored also. This is general relation. But inorganic means mostly exceptional cases only will come. Clear? Generally, where paramagnetic property is present, there color property is present. These are simultaneous properties. If one species is paramagnetic, that should be compulsorily colored only. No doubt in that. But exceptionally, very, very important point. Nitric oxide is a paramagnetic but not colored. Now what I am going to explain is a paramagnetic but not colored. Why? Single electron is present. Paramagnetic similarly it is colored also, but it is not colored. See the explanation. I am giving that point. It is colorless oxide. Why? See, if single electron is present, the visible light energy is not sufficient for the excitation of this single electron. That's why it is not colored. It is a paramagnetic but not colored. Why? Reason is the visible region wavelength is not sufficient for the excitation of this electron. That is the reason. So we'll write the reason also. Visible light is not sufficient. Just a second. Hello? Come up. Class is going. Come. Come. Already class started, Aisha. 4:30. Class started at 4:30 only. Visible light is not sufficient for the excitation of electron. Okay. Online students, are you following? Hello, everyone. Surabhi. Yeah. Once see all of you, Aisha, look at this. Nitric oxide. See the points. Neutral oxide. Number of electrons in nitric oxide is 15. Let us write a molecular orbital configuration. If we write a molecular orbital configuration, we are getting one single electron in the anti-bonding molecular orbital. So single electron is present, that's why it is paramagnetic, but it is not colored. Why? Because visible light is not sufficient to cause excitation of that electron. Okay, learn these points only, enough. Okay, compulsory we may get question based on the nature, means like neutral or acidic or paramagnetic or diamagnetic, like that all, colored or colorless, enough. Okay, once upon a time we have preparation methods. Okay, now it is no need to learn the preparation of oxide. Clear? First oxide is over. Next, second one, NO2, nitrogen dioxide. It is a brown color gas. And count electrons in this. How many electrons are present? Number of electrons. Please count number of electrons. See, oxygen 8, atomic number 8, 8 plus 8, and nitrogen 7. Total how much? 20. 8 plus 8, 16. 16 plus 7, 23. 23 is even or odd number? Odd number. So if odd number of electrons are present, paramagnetic. So this is also paramagnetic oxide. Paramagnetic. But colored, that is the difference. Previous oxide is paramagnetic but colorless. This is paramagnetic and colored. I mentioned already about color. Paramagnetic oxide, very important. Nitrogen dioxide is a paramagnetic. How many of the following are paramagnetic oxides? NO is a paramagnetic, NO2 also paramagnetic oxide. Once look at this reaction, NO2 at low temperature, minus 11 degrees centigrade, at low temperature, minus 11 degrees centigrade, undergo dimerization. Dimerization means two monomers combined to form a big molecule, that is called dimerization. N2O4. Okay, once see, NO2 is a colorless gas. It is a colored gas, brown color. It is colored. Its dimer is colorless solid. What about its magnetic behavior? Once look at this. This is paramagnetic. This is diamagnetic. Its dimer is diamagnetic. Why it is diamagnetic? Once look at this. Here how many electrons are present? 23 electrons are present, right? Odd number of electrons. Diameter means 23 plus 23. 23 plus 23, 46. Even number. That's why it is diamagnetic. So monomer is paramagnetic. So dimer is diamagnetic. Monomer is colored. Dimer is colorless. Right? Brown color gas is NO2. At low temperature it undergo dimerization. Okay? Note down the points. So these basic points, memory based only, there is no logic in this, by hearting only. Okay. Did you watch 50A group remaining? 50A group. Did you complete this? Shall we go to next page? Third one. Next, third one. N2O3. N2O3. See, one important point is there related to N2O3. See, it is called as sesquioxide. Sesquioxide. What is sesquioxide? See, if any compound is present in this format, see, M2O3, 3 oxygens and other element atomicity is 2. Oxygen should be 3, other element atomicity should be 2 only. That is called as sesquioxide. If any compound is present like this, O3 should be present and remaining element atomicity is 2. That is called as sesquioxide. See, this is in M2O3 format only, sesquioxide. See, this word is used to any compound which is present in this format. For example, if I write like this AS2O3, then I can call this also sesquioxide. But we are particularly discussing nitrogen oxide now. So which nitrogen oxide is a sesquioxide? N2O3. That is important point. Which of the following is a sesquioxide? Next, very important point. It exists as a blue color liquid. It exists as a blue color liquid. Blue color liquid at minus 30 degrees centigrade. Which of the following is a blue color liquid? In objective exam, several times questions came in their color. Oxide's color, magnetic behavior. Okay, which of the following oxide is a blue color liquid? N2O3 is a blue color liquid at which temperature? Minus 30 degree temperature, lower temperatures. Then what happens if you increase the temperature? See, N2O3 is a blue color liquid at minus 30. When you keep this at room temperature, it undergo decomposition to give NO2 and NO. Okay, NO2 is a brown color gas, we know that. At room temperature it is not stable, it undergo decomposition. At low temperature only it is stable. Okay, minus 30 degree centigrade, it exists as a blue color liquid. Very important point. Clear? Memory based only, dry topics only, there is no logic, directly by hearting only. Clear? One by one you have to read and you have to do the practice. Clear? Right. N2O3 is over. Next. Next, N2O. What is its name? Nitrous oxide. N2O. It is neutral. Oxide. Did I mention about neutral or stick at first? How many neutral oxides we got up to now? Nitric oxide and nitrous oxide. You know, in 10th standard, 9th standard, you already learnt about this, I think. What is chemical formula of laughing gas? Nitrous oxide. It is commonly called as laughing gas. When you inhale this, you will get historical laughing, called as laughing gas. Enough? Okay. Nature and general name. Once upon a time we have preparation methods, properties of oxide. Clear? Now basic information only. That too, this is first element now. That's why we are discussing oxides of nitrogen only. There is no need to discuss oxides of phosphorus. According to NEET syllabus, unique features of first element only given. That's why we are discussing nitrogen oxides only. Right? Next, last one. N2O5, N2O5. Dinitrogen pentoxide, N2O5. Which of the following oxide exists as solid at room temperature? N2O5. It is solid. It is solid at room temperature. All these are very, very important point. Don't skip any point. I already filtered and giving. Okay. So after reading, take white paper and write all the points without seeing. That is only the technique, because there is no concept, there is no logic in this. Total dry memory based on about oxides. Clear? Reading and taking the paper and writing without seeing. That is only the trick. Next. Completed? Once you tell me, we discussed some oxides. Say the names. Which is paramagnetic oxide? Online students, paramagnetic oxide. Surabhi. NO is a paramagnetic. NO2 is a paramagnetic. Okay, which is brown color gas? Which oxide is brown color gas? NO2 is a brown color gas, which exists as a blue color liquid. Blue color liquid at minus 30 degrees centigrade. Or which of the following is a blue color liquid? N2O3. Which of the following is sesquioxide? N2O3. Which of the following is solid at room temperature? N2O5. Like this only you have to prepare. Clear? Right. Completed? Shall we go to next topic? Online students. Surabhi, are you following? Surabhi? Obed, what about you? Obed. Bhakti. 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 This is about oxides. Right? Now keep it in dinitrogen. First element preparation. First element nitrogen. It's a dinitrogen preparation is there. Dinitrogen. Dinitrogen preparation is there. Preparation is important. Roman number 1. Roman number 1. From azides. From azide. Ultra pure nitrogen is prepared from azides. Which of the following is the best method to get ultra pure dinitrogen N2? From azides. From azides we will get ultra pure dinitrogen. Okay. That's why I'm mentioning, highlighting that point. Ultra pure N2 can be prepared. Can be prepared. All these are previous questions, weekend questions, previous exam questions. That's why I'm highlighting that points. Okay, if I highlight that point, means that came in the weekend exams or objective exams, PYQ. Clear? Ultra pure nitrogen is prepared by which method? From the azides. What is azide? Let us see. Oh. Okay, Bhakti, I allowed. First one, barium azide. Barium azide. Barium azide. Formula of barium azide. BaN3 taken twice. BaN3 taken twice. So how to remember this formula? See, azide ion. Once look at this. Azide ion. N3 minus. N3 minus is called as azide ion, right? What is barium oxidation state? What is barium oxidation state? Barium shows +2 oxidation state, right? In order to satisfy +2 charge, how many negative charges we require? How many positive charges are there? 2. How many negative charges we need to neutralize? 2 positive charges are there. We need how many negative charges to neutralize? 2 negative charges. That's why I'm taking 2 times. Okay. Are you getting how to remember the formula? Online students. Barium is +2. So we need -2. But N3 is having -1 only. That's why I'm taking twice. Is it okay? Clear only, na? Formula. See, simple heating of barium azides, delta Ba plus 3N2. See, nitrogen is produced, nitrogen gas is produced. Simple heating of barium azide gives N2. Barium and nitrogen will come out. First method. Similarly, we can use sodium azide also. Sodium azide, NaN3, sodium azide. Sodium azide, delta sodium plus N2, 3N2, 6. We can keep 2 here and 2 here. Okay, to balance the equation, or we can write directly, no problem. Sodium and N2, nothing will happen. This is not stoichiometry, no? So balancing is not important. Products are important, barium and nitrogen, that is enough. If you feel difficult in balancing equation, no need to learn balancing equation. Products are important. What are forming on the right side? Barium is forming and N2 is forming, that is enough. You no need to remember 3, no need to by heart 3. Okay, barium is forming and N2 is forming, that is enough. Right, first preparation method is over, dinitrogen preparation method is over. Ultra pure nitrogen is prepared from the azides. Next, second preparation method, Roman number 2. Shall I clear this? Adiba, Roman number 2, from NH4 taken twice, Cr2O7. Can you guess its name? Anybody? Can you guess its name? Yes, ammonium dichromate. Ammonium dichromate. Inorganic is total memory based only, girls. Practice only important, clear. But guidance also very important. Means at which point you have to focus, that is also important, clear. Dichromate, ammonium dichromate upon heating. You should remember the colors also. Colors: orange crystal, ammonium dichromate, orange crystal. Upon heating, produce Cr2O3, green solid. Remember colors also, because once in JEE means NTA given this question, that's why better to remember the colors also. Green solid, actually this is byproduct. What is our aim? Our aim is to find produce N2, dinitrogen. Nitrogen is produced. See, this is our main compound. Along with N2, green solid is produced. What is the oxidation state of chromium in that green solid? Like that, extensions will come, extensions. Or what is the format of that green color solid? CRO, Cr2O3, like that. Sometimes we'll get questions about byproducts also. Okay, related to byproducts also. Cr2O3 is the byproduct. Okay, not CRO, Cr2O3. And the color is green color, right? Ammonium dichromate is orange crystal. So this is second method for the preparation of N2. First method is azide, second method is ammonium dichromate. Okay, the third method, ammonium nitrite. See, not nitrate, nitrite only. Ammonium nitrite, NH4NO2. Upon heating, produce N2 plus H2O. We can balance the equation. 2 nitrogens are there. How many hydrogens are present here? 4 hydrogens are present. So can we keep 2 here? If we keep 2, then it is balanced, right? Balancing is not important. If you know, then write, otherwise no need. What is the important point here? You have to write N2 and H2 on the right side. That is important. Okay. How many preparation methods are up to now? 3 preparation methods. First one is azide, second one is ammonium dichromate, Next, ammonium nitrite, not nitrate. Remember, nitrate means what is the formula of nitrate? NO3. NH4NO3 is the nitrate. NH4NO2 is the nitrite. Okay. Next preparation method. Fourth one. The preparation methods are very, very important for objective. Okay, don't skip. In your schedule, this is not mentioned actually. Dinitrogen preparation is not mentioned, but we have to discuss. Here, chromium oxidation state. Here only. Find by normal method, regular method. This is unknown element is X. This is X. This is minus 2. 2 into X, 2X. Minus X is equal to 0. X is equal to plus 3. Normal method, finding oxidation state. Okay. Here chromium oxidation state is plus 3. Stoichiometry. Once I'll revise stoichiometry for all. Okay. One day we will plan for that. Main topics, basics. Next preparation method. Fourth one. From urea. Preparation from urea. What is urea formula? NH2 C double bond O NH2. Urea when treated with HNO2 nitrous acid. It produces N2. See else. Wait just a second. If you know, okay, we can prepare N2 from urea, that is enough. In addition to that, you have to write byproducts also. How to write the byproducts? See, N2 is over, production of N2 is over. Now, writing byproducts. CO2, here carbon is there, so imagine like that, CO2. Hydrogen is there, so H2. Don't bother about by numbering coefficients. I am also not giving, okay? N2, CO2, H2, enough. Don't waste the time on balancing unnecessarily. Clear? So what happens when urea treated with HNO2, nitrogen is produced along with nitrogen, water and carbon dioxide is produced. Enough. Okay? Now done that one. From air, you know, in air majority of the gas is nitrogen gas, so air is a good source of N2 gas, correct only, no? In air nitrogen percentage is more, I given at the beginning, 78% by volume, 75% by weight at the beginning of the class I given. So air also good source of N2, but how we will get the nitrogen from the air? Statement type questions only will come. Fractional distillation of air. Fractional distillation of air gives N2. Fractional distillation. Fractional distillation of air produce N2. So 5 methods are given to you. But frequently asked question is ultra pure nitrogen is prepared by dash. This is only, and this will be there in your material also, I think. Once check. First method. Okay. Next, keep heading. Completed. Shall we go to next page? Online students. Surabhi. Follow అవుతున్నారా మీరు? Surabhi and Bhakti. Bhakti ఉందా క్లాస్లో? Next, keep heading. Atomicity. Atomicity. Nitrogen is diatomic. Nitrogen is diatomic. It exists as N2 in the nature. N2 in the nature. Reason is very important. Reasons will come. Why nitrogen is diatomic? Why nitrogen is diatomic? Due to its ability to form multiple bonds. Nitrogen can form triple bond. Multiple bond means triple bond. Why nitrogen exists as a diatomic molecule? Due to its ability to form multiple bonds. This is important. Statement type questions will come. Don't get confusion. Okay. What is the reason for the diatomicity of nitrogen? Due to its ability to form multiple bond. Multiple bond means triple bond. Double bond, triple bond. These are multiple bonds. Single bond, double bond, triple bond. Double, triple can be called as multiple bonds. Clear? Nitrogen is inert, chemically inert. Why? Because of triple bond. It is used to create inert atmosphere. For example, you need some inert atmosphere in this room. If you send N2 in that room, then inert atmosphere will be created. So means in that room, that chemical reactivity is very less. For example, A and B are reacting in this room. They are highly reacting with each other. When we add the two, they will react more. But after passing N2 in this room, N2 creates inert atmosphere. They won't react with each other. Clear? Because it is inert due to multiple bond. And one more note also. Let us consider NN bond energy. NN bond energy is X. NN bond energy is X. Okay. I given about NN single bond, PP single bond energy comparisons in the previous classes. Okay. If you didn't listen the classes, watch the videos. I given NN PP bond comparisons. Let us consider if NN bond energy is X, then what about N triple bond N bond energy? Question mark. I am giving some options to you. Guess the answer. Option A, 3x is equal to 3x, less than 3x, C greater than 3x. D cannot be predicted. Guess the answer. What may be the answer? N single bond N bond energy is X. But here how many bonds are there? In between N and N, 3 bonds are there. So answer may be 3x. Can we multiply with 3? Generally, we'll do like that only. But no. But see, this is NN bond energy. N double bond and bond energy. N triple bond and bond energy. Clear? Single bond energy is less. You can break single bond easily. If I hold like this, you can cut easily. Yes or no? If I hold like this, can you cut? No. If bond multiplicity increases, bond energy also increases. See, sigma bond formation after 2 pi bonds formation takes place. Okay? Because of multiple bond, triple bond bond energy is more than single bond. Means 2 times or 3 times. Means greater than that. If we take directly 3x, that may be wrong. Bond energy is more than expected due to more stability of triple bond. If you multiply directly 3, if you count like this for one single bond x, for 3 bonds 3x, that is not correct. NN is single bond energy, but what about this? A triple bond is there. Triple bond energy is more. Clear? So answer will be greater than 3x. Because of pi overlapping, bond strength is more than expected. Clear? If you calculate like this, it is wrong. NN is x, 3 bonds are there, so 3x, that is wrong concept. Due to more bond strength, okay, the value is greater than x. Don't multiply directly with the 3. Okay, this is also a model question. Right, in your material or any weekend exams it will come. Clear? Adiba, got it? Surabhi, Bhakti. Obed. Atomicity of nitrogen is 2, diatomic. Remaining elements atomicity: phosphorus, arsenic, antimony. These elements atomicity is atomicity. Guess. Atomicity 4. They exist as P4, AS4, Sp4, arsenic. And bismuth is a metal. Bismuth is a metal. It present as a metal crystal. Okay, we cannot say atomicity. It is having layered structure in its metal. Bismuth. So these three elements atomicity is 4. Bismuth is a metal. It is having layered structures. We cannot say its atomicity. Okay. Nitrogen is diatomic, and I given the reason also. P4, AS4, Sp4. Next. Catenation. What is catenation? Catenation, self-linkage of elements to form a long chain is called as catenation. Phosphorus exhibits catenation. Phosphorus shows catenation. In these elements, phosphorus shows catenation. More catenation power is possessed by phosphorus. Last concept is very important. Okay, allotropy. Question coming area in the objective exams. They are asking the questions frequently on the allotropy in the objective exams. Allotropy in every group, 4th, 5th. Keep it in. This is a separate topic, so listen carefully. Allotropy. What is the definition of allotropy? Allotropy. It is a phenomenon of existence of one element in different physical forms. Clear? For example, not a suitable example, but I will give this example. Water exists as a solid ice. Water exists as a liquid. Water exists as a vapor. Correct? Similarly, in the nature, some elements exist in the different physical appearances. For example, take carbon element. Carbon exists as a diamond. Diamond is a shining, glassy, transparent material. Same carbon exists as a coal also. Coal is a black color material. Element is same only. In diamond, carbon is present. In coal, carbon is present. One element only exists in the different physical forms, physical appearances. That property is called as allotropy. Allotropy. Except bismuth. Except bismuth. Except bismuth, the remaining elements exhibit allotropy. Except bismuth, the remaining. Every point is important. When we write one point on the board, you should read compulsory. I won't give unnecessary points. This is also one question only. Which of the following do not show allotropy? Clear? So bismuth do not show allotropy. Except bismuth, remaining elements exhibit allotropy or show allotropy. Yeah, I'll give that only. Clear? Bismuth do not exhibit allotropy or nitrogen allotropy. Nitrogen in solid state. Nitrogen in solid state means when nitrogen gas is condensed to liquid after solidifying. Can we convert gas to solid? Yes. First gas can be compressed to liquid. Then liquid can be converted to solid or not. That's why I used the word solid state. Nitrogen exhibit allotropy in which state? Solid state only. In solid state it shows two types of allotropic forms. Alpha nitrogen and beta nitrogen. Alpha nitrogen and beta nitrogen. Gaseous state. Gaseous state do not show allotropy. Nitrogen exhibit allotropy in which state? Solid state only. Alpha nitrogen and beta nitrogen. Right? Bhakti, Ubaid, Surabhi. Shall I clear this? Next, phosphorus. Very important. Most important. Allotropes of phosphorus. White phosphorus. Atomicity 4. P4. White phosphorus exists as a tetraatomic molecule P4. P4. Once stop writing. If you write, just stop writing and listen how questions came and will come. Previously how questions came and how you'll get questions in the weekend exams also about white phosphorus. First of all, you have to remember the structure of white phosphorus P4. Four phosphorus. 1, 2, 3, 4, 6. Clear? First of all, you have to remember this structure. Angle between these bonds 60 degree. 60 degree. Once observe very important points about this structure. Number of pp bonds. All these are expected questions about white phosphorus, most important allotrope. Okay. Number of pp bonds. Count the number of pp bonds. Surabhi, can you count how many pp bonds are present? Are you there, Surabhi? Surabhi. Bhakti, am I audible? Am I audible to you? Is there any waiting room? Anybody? Sorry? Audible only. Guess, count the number of pp bonds. Adiba, you count pp bonds directly. 6 pp bonds. Okay. How many lone pairs are present in that? How 4 lone pairs are present on it? Number of pp bonds. See, Aisha, 1 pp bond. 1, 2, 3, 4, 5, 6. pp bonds. Phosphorus bond. Phosphorus. How many pp bonds are there? 6 pp bonds are there. Okay. Lone pair. Each phosphorus is having 1 lone pair. So total how many lone pairs are present? 4. Number of lone pairs. 4 lone pairs. Next. See, all of you, bond angle I already mentioned. No? Bond angle is mentioned. Most important part, highly unstable. Highly unstable. Due to bond angle style. Bond angle, see, let us consider this is one bond, this is one bond. Now you tell me what is the angle between them? 180 or not? 180. Now 90. Now less than 90. Then bonds are very close, na? So repulsion takes place. That is called bond angle strain. When bonds are present like this, they are stable because angle is 180. There is no repulsion. When you decrease the angle, what happens? Bonds come close together and they repel with each other. That is called bond angle strain. 60 means less than 90 means like this only, na? This is 90. This is 180. 90 less than 90. 60 means less than 90 only, na? Unstable. So very important point. Why white phosphorus is unstable? Due to bond angle strain. Very, very important point. Highly unstable due to bond angle strain. Due to bond angle strain. Hello? చెప్పండి. యా మేడం నేను క్లాస్లో ఉన్నాను, మళ్ళీ చేయమంటారా? నేను క్లాస్ తీసుకుంటున్నాను. రైట్, సరే. Highly unstable due to bond angle strain. Due to bond angle strain. Highly unstable due to bond angle strain. Very important point. Next, what is the geometry of this structure? What is its geometry? What is the geometry of this structure? Tetrahedron. P4 is tetrahedral. This is a tetrahedron. Next, so many points are there. Okay, take one tetrahedral structure. Imagine a prism. You know prism, glassy transparent material. Prism in physics. You don't know prism. How many trigons, sir? Not tetragon, trigons, sir. Trigons. How can I show prism? For example, look at this charger. This is having how many? This is tetragon. Tetragon means how many corners are there? 4 corners. 1 tetragon, 2, 3, 4, 5, 6, like that. This face is formed by how many corners? 4. So this is tetragon. Trigon means which is formed by only 3 faces only. This is trigon. Okay. In this, how many trigons are present? 4 trigons are present. Means faces which are formed by 3 centers. This is a trigon. Like this, how many trigons are there? In that, 4 trigons are there. Just you Google the prism, then you can understand. Take the prism and see the faces. Okay, like this. Here 3 faces are there and bottom 1 face. Now it is clear. 1 face, second face, third and bottom 1 face. Okay, 4 trigons are present. Next, oxidation state. What is oxidation state? What is oxidation state of phosphorus in P4? Oxidation state is equal to 0. Very good. Covalency. Around phosphorus, how many bonds are present? Around each phosphorus, how many bonds are present? 3 bonds. Covalency is equal to 3. Completed. So unstability is important. Next, poisonous in nature. poisonous in nature. White phosphorus is poisonous in nature. See how many theoretical points are coming. Poisonous in nature. Unstable means highly reactive or not? Unstable means highly reactive. Highly reactive. Highly reactive. Why it is unstable? Aisha, why it is unstable? Due to bond angle strain. Highly unstable due to bond angle strain. Due to bond angle strain. Highly reactive. Highly reactive. So it should not comes in contact with air because it explodes. It will produce flames because of its high reactivity. That's why it is stored under water. It is highly reactive, so stored in water. Stored in water. Sorry, water only, not kerosene. Kerosene is sodium metal. Sodium metal is stored in kerosene. Completed. Theory points only. Reading and taking the paper and practicing. That is one. Theory based questions will come directly. Structure also given to you. Okay, and additional information, bond angle data, number of pp bonds are given to you. Number of electron pairs also given to you. Covalency, oxidation state, everything is given. Poisonous nature. In night time, when it comes in contact with air, it glows. Flame will be created. That is called as chemiluminescence. You know, in burial grounds, from human skeleton, that fox dig that bones. Then white phosphorus present in the bone comes out and comes in contact with air, so flame created. Okay, that's what people will think that is a ghost. Okay, unnecessary flame will come automatically when phosphorus comes in contact. In our bones, phosphorus is present now. These foxes go for food night time, so they take the bones from the earth. Okay, from the burial ground. So this phosphorus comes in contact with air and flame will be created, and people think that is a ghost. It shows chemiluminescence. The property of glowing phosphorus is called as chemiluminescence. That is additional information. Okay, right. Next, white phosphorus is over. Now keep heading red phosphorus. Red phosphorus. Red phosphorus. Atomicity is same, P4 only. Atomicity is P4. White phosphorus, red phosphorus, atomicity is P4 only. Clear? See, white phosphorus is highly unstable. No? White phosphorus is highly unstable. Red phosphorus is stable. It is stable. Stable allotrope. It is stable. Stable allotrope. It is stable allotrope. Why it is a stable? I tell you. Why it is stable. See, we have drawn white phosphorus structure previously. White phosphorus. Similar to white phosphorus only, red phosphorus structure. Let's look at this. Right. Here, don't join these two. Draw another tetrahedron here, like this. Draw another tetrahedron. Once look at this. One tetrahedron, another tetrahedron. Link. One tetrahedron, another tetrahedron. Link. Got it? Clear? It is stable. See, the reason for its stability due to polymeric chain structure. Polymeric chain structure. So it requires more energy to break this polymeric chain structure. Previous one is single tetrahedral unit only. This is a polymer. More energy is required to break this. Clear? It is more stable. and exist in polymeric chain structure. Completed. Red phosphorus is stable. Once look at this transition temperature. What is transition temperature? The temperature which is required to convert one allotropic form to another allotropic form is called as transition temperature. Temperature required to convert one allotropic form to other allotropic form is called as transition temperature. White phosphorus 573 Kelvin. When white phosphorus is heated at 573 Kelvin, temperature value is also important. Okay, it will give red phosphorus. This is called transition temperature. 573 is the transition. Why? When you heat at this temperature, white phosphorus converted to red phosphorus. Clear? And red phosphorus when heated at 803 Kelvin. 803 Kelvin under high pressure, 803 Kelvin, it gives alpha black phosphorus. Chance is there to get the questions on these. Okay, here you will get X is the allotrope of phosphorus when heated at 573 gives Y. Another allotrope of phosphorus Y upon heating at 803 Kelvin gives Z. What are X, Y, Z? White phosphorus, red phosphorus and alpha black phosphorus. Okay. Got it, all of you? Online students. Bhakti? Shall we go to next page, all of you? Obed. Right. Now keep last topic heading uses. Uses of 50A group elements and their compounds. Uses. Adiba, are you following? Uses. See, under uses, I'll explain one small topic to you. Holmes signal. Holmes signal. The chemical compounds used in Holmes signals. Okay. See, calcium carbide, CaC2. This is, several times coming in the weekend exam. What is the composition of Holmes signals? Holmes signals. Calcium carbide, CaC2. calcium phosphide. See, phosphorus is 5th group element only, na? So calcium phosphide is the compound made up of phosphorus or not? That's why we are discussing this Holm signal. What is Holm signal? We will discuss. First of all, write the composition of Holm signal. Calcium phosphide. Calcium phosphide. Calcium phosphide. Composition first. Frequently coming question in your weekend exams is what is the composition of Holm signals? Calcium carbide and calcium phosphide. Ca3P2, CaC2. What is the use of this mixture? Calcium carbide and calcium phosphide. Let us see. కీర్తి చెప్పు. హలో, చెప్పమ్మా. కీర్తి, నేను మళ్ళీ కాల్ చేస్తా, క్లాస్లో ఉన్నా. నువ్వు మెసేజ్ పెట్టమ్మా ఏదన్నా ఉంటే, సరేనా? మెసేజ్ చేయండి. నువ్వు ఒకసారి మెసేజ్ పెట్టు నాకు, ఓకేనా? కాల్స్ కొంచెం ఇప్పుడు లిఫ్ట్ చేయకపోవచ్చమ్మా, ఎందుకంటే కాలేజీలో క్లాసెస్ ఇక్కడ కూడా స్టార్ట్ అయినాయి కదా మనకి. నువ్వు నాకు మెసేజ్ చెయ్యి, ఎప్పుడే ప్రాబ్లం ఉన్నా నాకు మెసేజ్ చేయి, సరేనా? ఎందుకంటే కాల్స్ నేను ఎత్తలేకపోవచ్చు. ఓకే, రైట్. Holm signals. You know, in oceans, on the oceans, ships will travel, okay, to carry the goods from one country to another country. Sometimes accidents will happen. Clear? They lose contact. They lose signals also, means phone signals. Then what they will do? That captains, what they will do? See, some containers are there. These much containers are there. In that containers, this chemical is present. This chemical is present. For example, accident is happened, okay, for the boat or any ship. Then what they will do? They lost the phone signal also. Phone signal and navigation also. Then what they will do? Some containers are there. In that containers, this composition is present. Holm signal. This is the container. Let us consider this as a container. Container having this chemical composition. That container is having small holes at the bottom. Holes at the bottom. They throw the containers into the sea. Okay. Then what happens? Water enter into the container through these holes. Through these holes. Okay. So inside container, what is present? This chemical is present, right? Okay. Now this calcium carbide or calcium phosphide, when comes in contact with air, then what happens? Look at this. Ca3P2 when comes in contact with water, it forms phosphine. Calcium hydroxide is the byproduct. Actually, this information is extra information only. You won't get anything. Just what is the composition of Holm signal by heart it. But if you listen to this story, then you can remember easily. Clear? Direct question is composition only. But I am explaining all these things. See, inside container, these chemicals are there. When these chemicals comes in contact with water, what is forming here? Phosphine is forming. Phosphine is highly reactive. It is having one property. When it comes in contact with air, it combusts. It produces flames, big flames with big smoke. So the driver, helicopter drivers or any other ship which is very far to the ship, then identify easily. Or some smokes are coming, some flame is coming, something happened like that. So other people can recognize this ship. Clear? So this flame act like a signal. Okay. For example, helicopter is searching for this ship. If flames will come, then that captain easily identify that ship. Na? That is the use of Holm signals. Okay. This phosphine is having the property to burn with a big flame and smoke. Similarly, calcium carbide also produce acetylene. When it comes in contact with acetylene is highly combustible. Okay. PH3 when comes in contact with air, produce flame. To that flame, acetylene will burn. So a big flame will be created. It acts like a signal light. You know, train signals. From the far distance we can observe green, red lights like that. That is about Holmes signal story. Clear? So the composition of Holmes signal is calcium carbide and calcium phosphide. Okay, first use. Next, shall we go to next page, girls? Online students. Second, nitrogen is used in cryogenic surgeries. Cryogenic surgeries at very low temperature, to create very low temperature. Cryogenic means low temperature conditions are called as cryogenic. Some surgeries carried at low temperatures. Some surgeries, okay. To create very low temperatures, liquid nitrogen is used. It is used to create very low temperature, cryogenic, right? And SbF3 is a fluorinating agent. SbF3 is fluorinating agent. Is fluorinating agent.